Lesson 8.1. This is going to be our introduction to quadratics. Our outcome today is going to be to define what a quadratic is. We're going to compare quadratic functions with linear functions, and we are going to define the parts of a quadratic function. Okay, please make sure that you take good notes. Okay, I cannot tell you how important of a unit this is and how challenging it's going to be. Okay, so I'm going to set that up from the beginning. All right, here we go. So first things first, we have two functions here. Let me zoom in on that just a teensy. There we go. That's a little bit better. All right, we have this one that looks a little U-shaped. I don't know that we've ever seen that before. And then we have this one, okay, where we have y equals 3x plus 1. One of these we have done before. Have we done A or B? We have done B. We've done this. This is a linear function, meaning it forms a straight line when you graph it. Now this one that forms this U shape, this kind of bowl that we form here, that is going to be our new guy, quadratic functions. Okay? Please make sure that you give yourself a sketch of both of these. You must know the difference between the two of these. Okay? All right, next thing. You can see all that? Perfect. Compare the two function tables below. See if you can write an equation for both. So here's what I want you to do. I want you to pause this, and I want you to copy down both function tables. And I want you to see if you can write the equation. One of them, you're going to be able to write the equation pretty quick. Okay? No big deal. The other might take a little bit of work. So pause, and then come back. All right, you're back now. So, which one were you able to write an equation for? I hope you're saying it's this one, because this one right here, the second one, oops, not that guy, is our linear function. This one forms a straight line. What was our constant rate of change? From here to here. From here to here. 4 to 6, that's plus 2. 6 to 8, that's plus 2. So our change in y over our change in x. What are we going up by x's? 1, we go up 1. So when we do slope, which one goes on the top, x or y? Good, y goes on top. So we have 2 over 1. That's our slope. What was our y-intercept? Where's this graph going to hit the y-axis at? Whoop, right there at 6, plus 6. So y is equal to 2x plus 6. Now, this one over here, if you haven't figured it out, he's going to be our quadratic. This one right here, okay? He does not have a oopsie, my bad. He does not have a constant rate of change. From here to here, we go down 1. From here to here, we go up 1. Oh my goodness, from here to here, we go up 3. That's a 3. And then from here to here, we go up 5. That's not constant. It's not going up by the same thing. Now, if you're Yael Flack and you're watching this, you know how to write this equation because you've done it before. I've seen you. Okay? All right. This one. Quadratic functions. Rate of change changes. Okay? You need to make sure you have that definition. You ready for the equation? Take 30 seconds, see if you can figure it out. Y equals x squared. Negative 1 squared, 1. 1 squared, 1. 2 squared, 4. 3 squared, 9. All right. On your linear functions, please make sure you have this definition. Linear functions, they must have a constant rate of change, our slope. They also have a y-intercept. Okay? All right, next thing. Here we go, quadratic functions. Here's an example of two quadratic functions. All right? You can just write down one of them. It's not important to write down both. But, well, I lied. Write them both down because look at the difference. One is opening upwards and one is opening downwards. And that corresponds to the different things in the front. This one you notice has a positive x. This one has a negative x. That's going to be important. Now, with this quadratic function, we have a couple of key words. Okay? We have the word vertex. That is this point right here. Let me get my pen so I can show you. Okay? It's this point right here. It's either the minimum which is this point right here on this one. Now this one, would that be minimum or maximum? Oh, good. That's going to be maximum because it's the top. Okay? So that's our vertex there. So I could put that word over here as well. All right? Now, the other word is the word parabola. That's this word right here. It is not said parabola. Okay? It is parabola. And that is the shape that this quadratic forms. That's the U shape. So let me get my highlighter here. That's the U shape, this U. That's called the parabola. So the function itself is called a quadratic, but the shape it makes is a parabola, not a parabola. All right, here we go. Take a minute, pause that. I'll read it to you. Just the math, the quadratic function. Okay, let me get my highlighter. That's going to be important. All right, I'm ready.
Maurice, call extension 206, please. Maurice, call 206.
Okay. The equation that you wrote for the area, that's a quadratic, y equals x squared, represents the simplest form. So that would be important. You don't have to copy this whole paragraph down, but you need to get the important stuff. Y equals x squared is the simplest form of a quadratic function. Okay? A quadratic function, important, is in the form, this right here could not be more important, right here. F of x equals ax squared plus bx plus c, where a, b, and c are constants. Also make sure that you note a can never equal 0. You can't do that. A can't equal 0. The graph of a quadratic, it's U-shaped. Okay? Again, make sure you have that down. That's the important part. Don't copy that whole definition. You don't need it. All right. Here's what you need. That is a quadratic function. This right here, I want you to draw an arrow and I want you to write, this is standard form. Standard form for a quadratic function is this guy right here. F of x equals ax squared plus bx plus c. Okay? All right, let's look at an example. So here's one right here. Okay? So a would correspond to which number? A would be 2, B would be 3, and C would be 5. So if I asked you what are the parts A, B, and C of this quadratic function, you would say A is 2, B is 3, and C is 5. We'll learn later what those numbers actually mean, but you just need to be able to identify them right now. All right, this was the other part that's important. Can you see that? Yes, you can. I can see it. Important note, A, B, and C are constants, just numbers. And A cannot equal 0. So A can never equal 0. Please make sure you have that part. That's important. Next. Okay. So we've talked about the parts of a quadratic function. Now you need to be able to evaluate each one. This is not rocket science, folks. Evaluate each of the following quadratic functions for a given value of x. If x is equal to 6, where are you going to put that 6? How many x's do you see in this first quadratic? 1, 2, 3. That's where I see it. So 6 is going to go in for all 3 of those. What it wants to know is, when x is 6, what is y? That's all f of x means. You could, let me get my pen. This is legal, I promise. You could take that f of x and just write a y. That's fine. It doesn't matter. Okay? So evaluate it for 6. You have 2 quadratics here, and I want you to solve them. Okay? So pause it for a minute and do that. Zoom in so you can see them. There's both of them. Okay? All right, you're back. Number 1. I'll just delete that. Here we go, because it's going to keep moving my page. Look, you plug 6 in. You've got to remember your order of operations. Exponents come first. 6 times 6 is 36. 2 times 36 is 72. Dagnabbit if I didn't make another mistake. I see it right now. Who caught my mistake? Who puts 3 times 6 is 15? 3 times 6 is 18 plus 5. Darn it. So it's not 92, it should be 95. Yes, 95. My bad. Feynman, you can have a piece of candy for every mistake I make. All right, x equals 6. Do it on this one. Let me zoom over there so you can see it. All right, get a good look at it. Plug in 6. We'll come back on the flip side, see if I made any mistakes. All right, here you go. 6 goes in. Now this one says g of x. Does that matter? No. It all could be erased and put... Here, let's take that. Let's put it over here. Let's make it y. All right, here we go. 6 squared, 36. I did that okay. 2 times 6 is 12, plus the 4. Add that all up. Hopefully it comes up to be 52. There's my ordered pair. 6, comma, 52. So when x is 6, my y ordered pair is going to be 52. All right, here's 2 more. You hurry up, pause those, and do them. Yep, you can see that. All right, you're back. Okay. This one I did put y, that's good. Here we go. 6 squared, 36. 36 times 5, hopefully that's 180. Plus 1, 181. The ordered pair, 6, comma, 180. Next. 6 goes in for x. Negative 6 squared, that's 36, plus 6, minus 5, should be 34. Hopefully I did my math right. You can tell me tomorrow. All right, that's it. That's just being able to plug in a value and go from there. You can do that. That's not hard. All right, here's a mini quiz. Here's what I want you to do. In just a second, I want you to pause the video, and I want you to write down these 6 functions. And I want you to say whether they're quadratic or linear. I'm going to be looking for this, so if you don't have it, you're not getting credit on your notes. Okay? Here we go. Write those down, and then just come back and I'll tell you the answers. Oh, let me zoom out. There you go. Now you can see. All right, number 1, linear or quadratic? Should have said linear. There's no x squared. All right, the little square, that's what is a dead giveaway that it's a quadratic. All right, number 2, linear or quadratic? Quadratic. There's my x squared, and it's in standard form. Number 3, linear or quadratic? Quadratic. Look at that squared on there. Number 4, linear or quadratic? Any squared? Nope. Linear. Number 5, quadratic. There's a squared. Number 6, come on, man. That should be a quadratic. That's all that you have to be able to do right now is tell the difference between a quadratic and a linear and know the parts. Let me go back. Oh, where'd he go? This right here, you better have that written somewhere big because that formula you are going to have to memorize. Okay? All right. This is the last thing that I have. You can zoom in on that to get the full website. But I just found it to be helpful. So it starts out www.virtualnerd.com, and then it goes Algebra 2, Quadratics, Graphing and Solving. It's just another helpful video. I found it real quick. You can try it out, see if you like it. It looks like this when you get there. Okay? What is a quadratic equation? She's going to tell you all about it. All right? So let me zoom in on that, see if you can see that a little bit better. All right? And if you want to go there, you can. End of quadratics number 1.